Hello class, today we're on lesson number 4, equivalent expressions. In chapter 5 we're on page 200. We look at the top of page 200. We have these 5 images and we read one type of question frequently asked on IQ tests is illustrated above. The figures are all alike except for one. Can you tell which one is different? Well, if we analyze the patterns here, we would note that in all but one, we can see a solid triangle with a solid circle to the left of the triangle. That is, if it's broken into these 4 different triangles, the solid circle is to the left. And you would obviously have to turn each of these to place them all, such as, let's say, the second image where we have the solid triangle with the solid circle to the left. So if you looked at the first image, it would be that way. The fourth image would also have the same pattern, and so would the fifth. But if you looked at the third image in the middle, you would notice that if you flipped it with the solid triangle to the bottom, the solid circle would be to the right. So that would be the one that's different. Now let's take a look at the following algebraic expressions. We have 2 times parentheses 1 plus x end parentheses. We have 2 plus 2x, and we have 2 times parentheses x plus 1 end parentheses, and we have 2x plus 1. Now, they are also alike except for one. So I'm going to go ahead and just pop these on here. I'm going to just paste them, and we have our images here. Let me get my pen back, and I can tell you right now that the second and the fourth one are not equivalent. And I can tell you simply because I know that 2 plus 2x can be rewritten as 2x plus 2. Similarly, I can write 2 plus 1 and 1 plus 2 equivalent as equivalent equations, or equivalent expressions rather. So if we were to write this, this would not be equal to this. So the question is, what are these two over here, and how could we best express them to determine what they are? Okay, so if we applied the distributive rule here, for instance, we would have 2 times 1, and that would be 2, plus 2 times x, that would be 2x. Okay, and again, if I were to follow, that would be like this one where we simply change it. I could write 2x plus 2. Okay, and again, applying the distributive rule here, I have 2x plus 2 times 1 would be 2. So we can see now that these are equivalent to each other, and the one that is not equivalent is the fourth one, 2x plus 1. Now, 2 algebraic expressions are equivalent if they're equal for all values of their variables. It is easy to see that the first 2 expressions are equivalent because of the distributive rule, so we applied that. Furthermore, the first and the third expressions are equivalent because the sum of the 2 numbers does not depend upon their order. So they're taking a different approach here. We could have just looked at these two here and said, hey, x plus 1 and 1 plus x are the same, right? We have 1 plus x and x plus 1, so we could have simply rewritten this over here as 2 times x plus 1, right? And we would have had the equivalent expression here, 2x plus 1. And then again, we are looking at the distributive rule in the first one. We could have applied the distributive rule and said, hey, this is equivalent to this. So that would have led us to a quick solution that this, and this were all equal. Okay. It is the last expression that is different. Okay. Now, it is important to be able to recognize algebraic expressions that are equivalent. The following properties of the fundamental operations will be helpful in doing this. First, you know that the sum of 2 or more numbers does not depend on either their order or the order in which they're added. These facts are called the commutative and associative properties of addition. So let's take a look at the top of page 201. Let me clear off my board here, and let's get rid of this, and we can start writing these. Now these are very important. These properties, you will carry them throughout your math lives, And so you should become very familiar with them. You do not necessarily need to know them by name, but you certainly need to understand how they work. And if you know them by name, it's very good. And obviously, for the sake of the exercises here, you will learn them by name because you will be asked them on the test. But what's more important is to understand how they actually work. So we have the commutative property, and we'll write that down, commutative. Excuse me, it's very difficult to write nice and neat with this pen tab. I assure you that I have much neater handwriting. So for any two numbers A and B, we can say commutative property of addition. Okay, so this is commutative, I'm just going to abbreviate, of addition. Okay, so I'm just abbreviating. And we can say A plus B is equal to B plus A. And we've given simple examples such as 1 plus 2 is equal to 3, the same as 2 plus 1 is equal to 3. Now there's also what's called the associative. And these words do have particular meaning. You can actually look up the words commutative and associative and better understand how they're being used in this context. But we have the associative for A, B, and C. Okay, and this is also the property of addition. I'm just going to write that here, of addition. And so what do we have? We have A plus B in parentheses, right? So we have A plus B and plus C, and that's going to be equal to A. Now notice the A is outside of the parentheses, and B and C are in parentheses. Okay? Now, one thing you must be very careful at, this is the associative property of addition, not of subtraction. There is no associative property of subtraction. So anytime you have subtraction going on in your equation, you must be very careful and do not misapply the associative property of addition. Nonetheless, we can see that A plus B, if you add these two together and then add C, would be the same as if you added B plus C together first, because remember we do order of operations using parentheses first, and then if you added that result to A. Basically, you can add all these numbers in any order, and you can certainly associate numbers. Okay, so we're associating A and B together, and in this case we've separated the A, where the C was separate here. Now we're separating the A and we're associating B and C. Okay, so that is the associative property of addition. Now we also have what's called the commutative property of multiplication and the associative property of multiplication. So I'm just going to leave these here and just say for multiplication, just for the sake of time and obviously my penmanship, we have of multiplication, and so we have the commutative and then we have the associative of multiplication. Okay, so how would we write these? Well, we would say A times B is equal to B times A. Okay, similarly, as we added A and B and B and A, we can multiply A times B and B times A. Simple 4 times 2 is 8, and so is 2 times 4. So simple example there. Now we can also do what's called the associative property of multiplication, where we're multiplying A and B first, then multiplying by C, and we can say that's the same as if you multiplied B and C first and then multiplied by A. Again, when we're multiplying, we can multiply in any order. If I were to say 2 times 3 times 4, I can multiply 3 times 4, then times 2. I can multiply 2 times 4, then times 3. So obviously you can put these in any order. So the commutative and the associative properties apply both to addition and to multiplication. Okay, now lastly we have the distributive, and we've learned this before. We're just going to start emphasizing this a whole lot more. This is very important, particularly when it comes to factoring equations further down the road. But it's important that you learn it one way so that you can learn it another way. And you could see the application of this knowledge in helping you solve more complex problems. So let's go ahead and write out the distributive rule or the distributive property of multiplication over addition and subtraction. And again, you're not new to this, or this is not new to you. A times parentheses B plus C is equal to AB plus AC. Oops, excuse me, I put the AC first. AB plus AC, where we're simply multiplying A times B and A times C, and we're adding them. Now, subtraction, well, we would have B minus C. So we have A times parentheses B minus C, and we can go ahead and write A times B minus A times C. Okay, so the relations between division, addition, and subtraction are not simple. Okay, if expressed in terms of the division sign. However, if division by A is expressed in fractions, we have the simple distributive property shown below. So we can now go ahead, we don't use division signs anymore, the quotient sign. We're going to use fractions. So let's go ahead and write our distributive property of division over addition and subtraction, where we have B plus C is being divided by A, and that would be the same as, and this is so important to understand, I cannot stress the importance, is B over A plus C over A. In other words, when you're adding two expressions or terms such as B and C, note that you're going to add these together both, and you're going to ultimately divide that by A. Well, if you were to separate this, as we did here, and say, well, you can take B and simply divide it by A, and similarly add that to C divided by A. A simple example might be 4 plus 6 over 2, right? Well, we know that's 10 over 2, so the answer would be 5. So what if I applied the distributive property of division? Well, that would be 4 over 2 plus 6 over 2. And 4 over 2 is equal to 2, and 6 over 2 is equal to 3, and we would get the same answer of 5 had we just simply added 4 plus 6 divided by 2, and we would have gotten 5. So you can see how this works. Very important to remember this, okay? It's different when we're multiplying, because when we're multiplying, it's a different application. We've created what are called factors. We're emphasizing here that there's addition as well as we can emphasize subtraction. B minus C over A is equal to B over A minus C over A. And again, if we did the same over here, I guess we would probably want to maybe use a positive number. Let's say 6 minus 4 over 2. Well, 6 minus 4 over 2 would be 2 over 2, which would be 1. Well, what if we applied our distributive property of division? We would have 6 over 2 minus 4 over 2. And 6 over 2 is equal to 3 minus 2 over 2, which is equal to 4 over 2, which means the answer is 1. So our answers would be the same had we applied it either way. So again, this is very important. You have some examples here. We'll go over that in another video.